Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell. Then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you see the links for the O-level and the A-level group.
Welcome back, students. This is Dr. Mlelwa Lecturers, and we are continuing with our topic of states of matter. The facilitator in this session, I am Dr. Mlelwa, and a graduate student at Mwimbi University of Health and Life Science. So I am continuing with the concept of mass percentage and mole fraction. In the previous session, we discussed about the concept of molality and normality, and we discussed all the formulas of molality and normality. So in this session, we are continuing. Mass percentage is the mass of solid in grams dissolved in 100 grams of solution. Mass of solid dissolved in 100 grams of solution. CO of solvent, it is of solution. So actually, in mass percentage, we are saying that mass percentage is equal to mass of solute divided by mass of solution times 100. So this is just by definition, but in calculation you can calculate mass percentage in this way. Now, because the definition of mass percentage has included 100 grams of solution, most of times when we are given mass percentage, or when we are told to calculate the mass percentage, as we shall see, we need to convert the units. So how we convert the units in calculation of mass percentage, we shall see later. But as we know, the mass of substance, mass of solution is equal to density times volume of solution. So mass percentage simply would be equal to mass of solute divided by density of solution times volume of solution times 100%. But as we know, mass of solute divided by volume of solute is equal to mass concentration. Now mass percentage is equal to mass concentration divided by density of solution times 100%. So simply this is the derivation of how can we calculate the mass percentage, and that's the concept of mass percentage. Now let's jump to discuss the concept of mole fraction. Mole fraction is the ratio of number of moles of a component to the total number of moles of all components in the solution or mixture. As we discussed the concept of mole fraction in gases, and we said that mole fraction is the ratio of number of moles of a component gas divided by the number of moles or total number of moles of all gases in the mixture. So even in solution, the definition and even the calculation or the concept of mole fraction remains the same. Kwa hiyo ni ratio number of moles ya component moja gawanya kwa total number of moles in the mixture. So it depends, you have how many components in your mixture, but taking the number of moles for one component divided by the total number of moles, it is what we call as a mole fraction. The symbol for mole fraction remains the same. It is represented as X. And assuming that we have many components, let's say A, B, and C, then total number of moles, total, let's say it's number of moles of A plus number of moles of B plus number of moles of C. So let's say the mole fraction of A will be equal to number of moles of A divided by number of moles of A plus number of moles of B plus number of moles of C. That will be the mole fraction of A. So one thing that you need to know is that if you add up the mole fraction of all components in the mixture, we need to reach the answer as a 1. So mole fraction of A, for example, plus mole fraction of B plus mole fraction of C would be equal to 1. If you don't understand this concept, just review my lectures on the gases. I explained this concept, but I hope if you look from the first session on the states of matter, it will be very easy for you to understand why do I say that the total of mole fractions should be equal to 1. Also, the ratio of mole fractions should be equal to the ratio of number of moles. This can be derived simply here. For example, if we have, let's say we have two components. We have component A and then you have component B. So number of moles of A, and then here we have number of moles of B. Mole fraction of A will be equal to number of moles of A divided by number of moles of A plus number of moles of B. And mole fraction of B will be equal to number of moles of B divided by number of moles of A plus number of moles of B. Now, if we want to take the ratios of mole fraction, it will be mole fraction of A divided by mole fraction of B is equal to number of moles of A divided by number of moles of A plus number of moles of B. And this is divided by number of moles of B divided by number of moles of A plus number of moles of B. So simply, number of mole fraction of A divided by mole fraction of B, it will be equal to number of moles of A divided by number of moles of A plus B. Then this is times number of moles of A plus B divided by number of moles of B. So number of moles of A and number of moles of A plus B, that is the total number of moles, will be cancelled out. So we'll end up with the mole fraction of A divided by mole fraction of B is equal to number of moles of A divided by number of moles of B. So this is the simple derivation of what we have said. And then let it end up here in this lecture, and in the next period or in the next session we'll be discussing about the concept of dilution and dilution principles before we have started the calculations on a solution. So one thing you need to understand in this session is about the concept of mole fraction. The addition ends up with the answer for 1, and the concept of mass percentage of a substance. So thank you everybody. Let I wish you nice studies. Don't forget to subscribe to the channel and to join my Telegram group for more discussions. Share and like this video.